Hi everyone, this presentation is given by Anjani, Jyotika and Sirisha, and today we'll be discussing machine learning for information retrieval or ML for IR. Our goal is to show how machine learning helps search systems from Google to Netflix and deliver smarter, more relevant and personalized results. So we will be covering the following topics in this presentation. We will introduce you to IR and how ML is used in IR, some core machine learning tasks in IR, and types of ML and how ML is approached in IR in like modern day, some applications, challenges, and tools, and how this can be in the future. So, information retrieval or IR is the process of finding relevant information from large collections of unstructured data like web pages, documents, or videos. Whenever you search on Google, Amazon, or YouTube, IR systems are behind the scenes, matching your query to best possible results. Traditionally, IR relied on keyword based models such as TF-IDF or BM25 which ranked documents by word frequency. But these models ignored context. They couldn't distinguish between apple, the fruit, or Apple, the company. That's where machine learning started to make very big difference. In a basic IR pipeline, there are three main stages: indexing, query processing, and ranking. So, indexing is text documents are tokenized and converted into structured data. And in query processing, the system processes the user's query to extract key terms. And in ranking, documents are ranked by relevance using similarity measures. But this traditional setup has limits. It depends heavily on keywords. It struggles with synonyms or polysemy and doesn't learn from user behavior. Machine learning helps overcome these limitations by introducing learning based ranking and semantic understanding. So, why bring ML into IR? Machine learning allows systems to learn from user interactions. When users click on certain results or spend more time on a page, the system adapts over time to show better results. ML also enables context-aware and personalized search. So two users searching the same query might get different results based on preferences. It's also used for query suggestion, auto-completion, and understanding intent of the user. For example, if you type best phones under 500, my ML models infer you're comparing affordable smartphones, not just browsing random devices. Now that we understand the role of machine learning in modern search systems, my teammate will explain the main machine learning techniques and their real world applications.
Myself Sirisha and I'm explaining the next slide. In this slide, we will look at the core machine learning tasks used in information retrieval. So information retrieval systems are designed to find the right information from huge collections of data. Machine learning enhances IR by helping it understand meaning, context, and user intent. So the first important task is ranking. So ranking decides the order in which search results appear. For example, when we search in the Google, machine learning models rank pages based on relevance and quality. So the most meaningful results appear first. So next is the classification. Classification is used to assign labels to text or documents. For example, emails are classified as spam or not spam, and news articles may be tagged as sports, politics, or technology. This helps recognize information and filter content effectively. And the other task is clustering. It groups similar documents or queries together without the predefined labels. For instance, search engines cluster similar search queries so users see related suggestions. It also powers topic grouping in recommendation systems. Then we have the query understanding. So this includes analyzing the user's input to understand the intent behind it. And also it involves like query expansion, predicting user intention, and correcting spelling mistakes too. When you type half a query in Google and it finishes the sentences for you. That is query understanding. And finally, the document presentation is crucial. It means converting the text into mathematical form so machines can process it. The techniques like TF-IDF, word embeddings, and transformer embeddings help systems understand the semantic meaning. So these core ML tasks work together to make the search system smarter, delivering the accurate, personalized, and meaningful results. So when coming to the next slide, there are different types of machine learnings which are used in the information retrieval. So the first type is supervised learning. In this, the models are trained using labeled data. So for example, we give the model queries and relevant documents, and it learns which documents should appear at the top. Applications include like ranking, classification, and intent prediction. So the second one is unsupervised learning. So in this method, the model analyzes patterns without labeled data. And also it is commonly used for the clustering, topic modeling, document grouping, and user segmentation. So for example, a news website may cluster articles into themes and it will automatically without the human labels. And the other one is the semi-supervised learning. So this model combines small label data with large unlabeled data and which is useful for the labeling. And also the example is a few queries are manually labeled and the system learns the rest from user clicks and search logs. When coming to the reinforcement learning, the system learns by interacting with users and improving based on the feedback. And the search engines use reinforcement learning by analyzing the clicks. If users click the first result open, the model learns and their ranking is correct. So the supervised, unsupervised, semi-supervised, and reinforcement learning all plays the key roles in developing the strong information retrieval systems. So now we are going to the modern machine learning approaches in information retrieval. The traditional IR is focused mainly on the keyword matching, but modern information retrieval uses models that understand the language, context, and user behavior. The first modern technique is word embeddings. So in this, the words convert into vectors and also the models understand semantic meaning. For example, king and queen becomes close in vector space. So the models like word, two-vec, glove, and fast text are widely used. So the next one is like transformer based models, which are like BERT, GPT, and all. These models use attention mechanisms to analyze the word relationships in sentences. And the transformers power modern search engines, question answering systems, and chat based search tools. And the Google search uses BERT to understand the intent behind the queries and improving the accuracy drastically. And the other approach is neural ranking models. So these deep learning models learn to rank the documents based on the relevance. They replace older rule-based scoring like TF-IDF and BM25. Neural models consider the full sentence meaning, use behavior signals, and the context. We also have the contextual embeddings where each word's meaning changes depending on its context. So, for example, the word bank means differently in riverbank versus the bank account. Contextual models handle that complexity. So together, these modern techniques allow information retrieval systems to understand natural language deeply and deliver more like human-like intelligent search results.
Hi, this is Anjani Vinda. Now I'm going to explain applications of ML in IR. Machine learning now powers almost every major search and recommendation system. In web search, models like Google's RankBrain and BERT personalize search results and handle complex natural language queries. In e-commerce, ML interrupts intent like running shoes for flat feet and ranks relevant items accordingly. In streaming platforms like Netflix or Spotify, recommendation systems predict what users might like next. In healthcare and legal tech, ML based IR helps professionals find precise context aware documents quickly. Now we are going to next topic, challenges and future directions. Even with these tools, there are ongoing challenges. First, bias and fairness. If the training data is biased, the system might produce unfair or skewed results. Second, explainability. Users often want to know why a particular result appeared on top. Third, privacy personalization requires user data, but it must be handled securely. And finally, computational cost, as deep models require powerful infrastructure. For the future, research is heading towards multimodal IR where text, images, and videos are processed together. We will also see few short learning enabling systems to handle new queries without massive labeled datasets. And explainable AI will make IR systems more transparent and trustworthy. Now we discuss about tools and libraries for IR. To build ML-based IR systems, developers rely on specialized tools and frameworks. Apache, Lucene, and Elasticsearch handle indexing and search efficiently. Scikit-learn helps apply traditional ML algorithms like logistic regression or SVMs for ranking. For neural IR, TensorFlow and PyTorch were widely used to train and deploy deep learning models, and Hugging Face transformers offer pre-trained language models such as BERT and Roberta, which can be fine-tuned for custom search tasks. Looking ahead, information retrieval is moving beyond simple text searches toward more intelligent, context aware, and multimodal systems. One major direction is multimodal retrieval, where IR systems will process text, images, audio, and video together. For example, allowing users to search for video similar to a given image or phrase. Another key trend is few shot and zero shot retrieval, where models can understand new topics or unseen queries without needing large label datasets. Thanks to large language models, the next is personalized retrieval will also become far more precise. Systems will adapt to each user's unique preferences and search history. Moreover, explainable IR will make ranking decisions more transparent, helping users to trust why certain results appear first. Finally, with privacy preserving methods like federating learning, future IR systems will deliver personalization while keeping user data secure. The future of IR is intelligent, adaptive, explainable, and deeply user centric. To conclude, machine learning has transformed information retrieval from basic keyword matching into a powerful, intelligent process that truly understands meaning and intent. Modern IR systems now leverage deep learning, neural ranking, and transformation based models to provide semantic search and personalized results. These systems not only retrieve information from but also learn from user behavior, such as clicks, time spent on pages, and previous searches, to refine for future recommendations. The scalability of machine learning allows IR systems to process massive data in real time across diverse domains like healthcare, e commerce, and education. Ultimately, machine learning makes IR faster, smarter, and more relevant, connecting users to the right information at the right time. The ongoing evolution of IR points to a future where search becomes conversational, contextual, and personalized for every individual. In summary, machine learning has redefined how we approach information retrieval, transforming simple keyword based searches into intelligent, context aware systems that understand user intent and meaning. From neural ranking models to transform based architectures, these technologies have made retrieval faster, more accurate, and highly personalized. As we move forward, the integration of multimodal data, explainable models, and privacy preserving techniques will continue to push the boundaries of what's possible. The future of information retrieval is not just about finding information, it's about understanding people, context, and purpose. Thank you for your time and attention. Have a good day.